Good morning, everybody. We got a few people still straggling in, but we're going to go ahead and get started with today's webinar. Thanks for joining us. This is part of a series that we're doing now for the year, kind of bringing about some better ways of optimizing your wireless technology. And we also get into a little bit deeper dives throughout the year of actually implementing some of these ideas and a little bit more the nuts and bolts of it in some net labs. Today we're talking about optimizing mesh technology, and it's something that's really kind of come to the forefront recently. A couple of quick things before we get rolling with this is down in the handout section actually is a copy of kind of the whole schedule of the webinars and the net labs that we're doing. If you want to grab that so you can actually see what's coming up and plan accordingly. Also, if you got any questions, go ahead and feel free to drop it, over into the question section, and we'll go ahead and get these answered as we go. This is actually a fairly short webinar compared to what some of you may have been involved with, so we'll kind of get things rolling and go through it. My name is Dan Tolley, Director of the Business Development out here at ESTeem Wireless. Also, we've got on here is Perry Weatherby. She's going to be kind of manning the questions. So we're going to kind of keep rolling through this. Kind of to let people know we've got some familiar faces, we've got some new faces, is really who is ESTeem. And so when we start looking at this, who we are is basically a company that we were formed back in 1982. So this is something that we've been doing for a little over 38 years. So we've got a lot of experience both in the design as well as the implementation of these wireless networks. And one of the things that really makes us unique is that we are actually the manufacturer. So we design and manufacture these specifically for industrial automation. This isn't something really that's designed to go into the homes or into more of a normal enterprise. There's a lot more of some rigors and some different temperature specs and just a harsher condition these are designed to go in. What that also means is that we have complete ownership of all the IP as well as the life cycle of these products. And this is from a hardware standpoint as well as the software. We control everything from kind of soup to nuts on our product line here. What that also does is it allows us to design backwards compatibility. So if you've got a network that may have gone in a few years ago, the current generation of product is also going to be backwards compatible for that. Everything that we do is made here in the US. We're headquartered and manufactured out in Washington State. Really what we have is a lineup of products or a portfolio that's the deepest within the industry. We actually have 10 different products, and we cover FCC licensed frequencies as well as the license-free or unlicensed frequency. And to date, we've got a little over 45,000 modems in service kind of across the world. Primarily, we stick to the Americas, both North and Latin America, but we do actually stretch the globe and have things kind of installed all throughout the country. So kind of where we delve into things is kind of the norm where we work in is our solutions are found within the water, wastewater markets, oil and gas, mining, material handling, power and energy, ag. We do factory floor automation, and then we also do a lot of kind of what we consider infrastructure, which can be anything from video cameras to just connecting to buildings. There's some kind of different ways to look at that, and we kind of lump a lot of things into that. And what we're seeing kind of throughout all these industries is part of this digital transformation that a lot of people are hearing about or talking about. And really kind of where we're sitting now is up at the top of that step in this industry 4.0. And what that really means, or what we're seeing here, is that we've moved from a serial-based communication scheme into an Ethernet base. So what we're doing is moving more from a device-level communication, and really the goal of this is to now, we're actually going through and we're networking all of these devices, or networking all of the total package of information we're trying to collect. So when we kind of take that forward is we've morphed now from a device level communication into a network level communication scheme. And we kind of get into what they call a connected model. And really there's really 4 pillars that this connected model is built upon. Is that we have the things themselves. Think of that as your cameras, your PLCs, your remote stations. things that are out there, those are the devices. And ultimately, the goal of all of this is to be able to get that data, do analytics on that over on the far side of that graphic. Now, in order to accomplish that, really we need two things: is we need connectivity to that data or to those devices, and then we've got to have basically somewhere to store that data or the data itself. And so these pillars that we're looking at is basically we want to get, the information from those devices on the left side, and then basically be able to analyze or act upon that, or actionable items, over on the right side. So we start taking this now and applying this connected model into kind of this industrial arena that we live in, is that we start looking at very unique challenges that we have within this. So typically this is going to be very long distances. Now this can be, citywide, it can be countywide. A lot of times we're trying to get across waterways. A lot of times we're trying to get across roadways. We may just be trying to connect two plants that happen to be on opposite sides of a freeway. A lot of times now we're dealing with mobile applications. Basically we're dealing with a lot of remote assets. So because of those challenges, really the biggest solution to this, excuse me, is to deploy a wireless network. So in order to start looking into these wireless networks, historically, this is kind of how they've always laid out, as we're communicating from different locations, and we tie all these together, and we have basically dedicated pathways for that communication to go. As things have advanced now in both speed as well as this network connectivity, as well as the value of that data, is that we want to have a way to make this more reliable. This is where we want to have redundancy. So we now start building in are these backup or these redundant pathways. Okay, so kind of when we look at this, is not only do we have our primary paths or the ways that we want the communication to flow, but should something happen, we want basically the ability to go to a backup path or self-heal ourselves. This is kind of the idea of what people are calling mesh. Okay, so before we get a little too far into it, we really kind of need to look at what is mesh. It's a term that's thrown around all over, and everybody does it a little bit differently. So really when we look at what mesh technology is, or what we term industrial mesh technology, is really kind of look at where it comes from. The term mesh itself is just basically as a buzzword. That's kind of one of the things with wireless technologies. There's a lot of buzzwords. Where that term actually comes from is back in, we call it Zigbee days, and this is part of the IEEE standard 802.15.4. Really what it was used for is that we had very low powered transmitters that would have to essentially relay the information, or kind of daisy chain this down in order to basically get it across a wider distance than what could be covered by those low power transmitters. That's kind of where the term mesh came from. Now, when we look at this today, what we're looking at is we're really using it for an entirely different purpose. What we want is kind of these self-healing, redundant backup communication paths out there. When we want these to basically be an automatic switching based upon conditions. It can also provide a canopy for your Wi-Fi coverage. So we can have a single point of entry onto a network, and we can now repeat that access point out to multiple locations without having to hardwire those access points. Really, the whole goal of this is really to assure data reliability between those devices. Okay, this really is built upon what we're doing is kind of the engine that runs behind this is just standard networking spanning tree protocol, and we support both spanning tree, rapid spanning tree, and multi-spanning tree protocol. And really what we look at is we want to kind of take that and then add a little bit more control to it. So what we've done is we allow that all these routes are completely configured, controlled, and prioritized by the user or by the integrator, so that we can direct that traffic exactly as we wish. We don't want to leave this to just specifically an algorithm. Ultimately, kind of the goal is that the self-healing creates reliability. So as we kind of take a little bit deeper look into that, and what does that actually mean when I start talking that those routes are configured and controlled? So if we kind of just take the left portion of that diagram there, and we take that out a little bit further, is so in this, again, what we're trying to do is control the data flow. So what we do is allow the user to configure this. And how that's done is done what we call path length. And there's a setting within the radios. Now, by default, everything has a path length of a 1. Okay. And so what you have to consider is that the overall path length is a sum of those individual parts. So for example, on this diagram, that direct link is going to have a path length of a 1. If we're going through that repeater, basically that is going to be our 1 up at the top, the 1 at the bottom. So that would have a total path length of 2. Okay. So in this case, what would happen is that we would see that we have basically that it's going to look at this as a 1 versus a 2. So in this case, the direct link would be our primary path, and then the going through the repeater, because it has a higher path length, would be the redundant backup path. Now, one of the things that we see in radio that's a little bit different than the wired world is that a lot of times the direct path isn't always the best. There's times in which we're going to want to force this through the repeater as opposed to taking the direct path, and we want to leave that direct path as a backup for it. So in order to accomplish that, again, we take that same thing, and if we want to kind of make it this way so that that repeater path is there, again, we have basically our 1s here. Now to overcome that, we can actually simply go in and configure this path to now be a 3. So again, we're looking at the sum and it compares those. So now all of a sudden we have a path length of a 3 versus a 2. So what this is now going to do is that this is going to force the primary path is going to go through the repeater, and the direct link is now going to be the redundant backup path. Okay, so we want to give you control to say this is my best path, whether that be based upon signal strength or data rate, in order for that to happen. Now the beauty of this is that it actually is we can build this out network wide. So when we kind of look at this in a large scale, we start looking at this with a series of primary paths. We have a series of redundant backup paths, and we can have multiple backup paths in order to overcome instances, whether it be a power outage or a lightning strike, any kind of thing in which we would lose a primary path. So as we kind of put this into motion now, so it makes a little bit more sense, as we take this operating network, and this is basically our communications are humming along, we're getting the data that we want. Now, all of a sudden, what we're going to have is that we have an event. Now, this can be something that, say, we may have a power outage up at that water tank. They may turn the power off in order to do some maintenance. There's a lot of things that can happen. So now, all of a sudden, what's going to happen is this is automatically going to switch, and we're going to go to that next priority path that you've identified. And we're going to basically reroute or self-heal around that basically issue. Okay. So now all of a sudden, again, this is happening automatically within the back, and there's nothing that you have to do other outside of the initial configuration. Same thing now, all of a sudden, if we were to have another event at that location, it's going to continue to reroute itself and heal so that we continue to get the data that we can. And as it just kind of continues to go down, now all of a sudden, if we happen to lose this one, now we've built these communication backup paths so that the ones that are on, we can now continue to receive that valuable data. Now, the other thing that's very, very important to this and what differentiates how we're doing the mesh side of things is that now all of a sudden when we return power or that unit is replaced or whatever, and we get those locations back, it's important that we now switch back to those primary paths on its own. So it's always looking and always trying to go to its primary path if it's available. Again, this is all done based upon spanning tree protocol. Okay, so again, we're basically now all of a sudden we can build all this in. Okay, so a lot of times when we're kind of talking through this, it's like, you know, that's great, everything is fine with that, but you know, is this complex? You know, how hard is this to actually configure into the radios? It really isn't. It's a very simple way of doing it. You can actually go in and make this to where you're defining it through a web page. But what we did is we went and created a utility basically so we can do very simple mesh network configurations. As you see, and you kind of watch this in motion, is that we can actually plot this and simply draw lines between the locations. Now, as you're doing this, not only are we kind of laying out how we want it to act, it's actually building the configuration files that we can then send to those radios. And this is just a Java-based application that is very simple to use. And why we went to a Java-based application is now all of a sudden it can run on whichever flavor of Windows you're running. You can run on a Mac, you can run on Linux. It's just a Java-based application. Now this is where we can actually go in on each link and actually change that path link that we talked about a few slides ago. So we can change that to a 1, we can change it to a 5, we can really start to alter or shape this network in with the way we want to go. Well, what this tool also allows us to do is as you hover, you kind of get a brief snapshot of that particular radio. IPs, we can look at, the MAC addresses of it. And once everything is done, we can actually go up to the radio tab, select this, move down, and now all of a sudden we can that network you've just configured, we now send it out to those radios. That's all there is to it. One of the other features of this is in the future, if there's other things that are added, is we can do a firmware update out to that same network as well. And one of the things that's also very powerful about this is that this is something that can be changed on the fly, say on your network. So if it's deployed today and there's certain network paths that say, okay, this is where we think we want to do, how do I actually make sure that that's where I want to go? Well, we can change that. We can always go back in and change that path cost to reshape the network flow. So one of the things that's also very powerful with this same piece of software on the mesh side of it is now all of a sudden we can take and run into what we call a monitoring mode. So what this allows us to look at is, if you can see on here, basically, so here's our pathways. It's going to show us the RSSI. This is the amount of signal that that link is producing. It has the data rate, which is this second item down here. Then we also get the connection status, meaning that it is a connected network, which is either a Y or an N. Now here's where we show if it's a redundant path or if it's going to be the primary path. And what you'll see is that these two links are in a forwarding state. This is going to be our primary pathways. This link would be in a blocking state because it's going to be considered the redundant path. Now all this data now, all of a sudden we can leave from monitoring. We may want to switch that so that we have a different priority path. Okay, make sense? Okay, so what we've taken is all of this information is available so that you can do that. And this mesh technology that we roll out is available within our Horizon series. And this is available in 900 megahertz, 2.4 gigahertz, and 5.8 gigahertz. All of these have the ability to do the industrial mesh technology to enable those redundant, self-healing, scalable networks. The other powerful part of this is any radio can go at any location. So it can be programmed as essentially as a master. It can be a repeater. It can be a remote. What it also has is different modes of operation. So not only can this be a straight AP bridge, but we can also put this into a router mode if we want to have different subnets across this. We can do IP masquerading, from a security standpoint. If you have a mobile application, they can also be put into basically we call a station mode. All of them support both layer 2 and as well as layer 3, kind of your bridge versus routed networks. All those links that we're doing, whether it's a redundant or a primary pathway, all that data is AES 256 encrypted connections. Okay, we just kind of talked about that Java-based utility that we can do there, and also it's got a memory module. We won't get into that in this instance on there, but really what it allows you is just to be able to save a backup configuration that you can then plug into another radio physically, as well, kind of the SIM card technology. Now the other nice thing is, not only are we providing this mesh technology or this mesh network, now all of a sudden in the 2.4 gigahertz and the 5.8 gigahertz, we can also be a Wi-Fi access point. So now all of a sudden, not only you're connecting your devices, you can be bringing in, say, your thin clients or your mobile workers out there on a tablet or laptop can actually Wi-Fi into these these networks on those frequencies. So again, the idea here is basically so that we can get this industrial wireless mesh technology or mesh network out there designed so that we have a good, redundant, reliable, stable network. As I mentioned kind of as we started this, this is part of a series, and what we're going to go to next, which is in a couple weeks, if you want to join us, is that we're going to get into conducting RF site surveys. Now, what this actually is going to do, kind of related to what we've been talking about today, now all of a sudden we can go test these links and decide which is going to be the best path or that primary path, or we can now get into which would be our redundant paths. And so that's all done in an RF site survey, and we're going to have a complete net lab on how that's conducted that Eric is going to do in a couple of weeks on the 25th. You can sign up there through our website as well. And that's kind of the gist really of what we're talking about today. I'm not sure if there's any questions that have popped up that we can kind of take a look at. Seeing that Perry's watching there, and I guess there is a question that's popped up is, how long does it take to switch between the main route and the backup route? So actually a great question. It really depends upon if we have these configured for a spanning tree network or a rapid spanning tree or multi-spanning tree. By default, these run at rapid spanning tree, meaning that convergence or reconvergence, if you will, or the time it takes to move from a primary path to the backup path, it's about 6 seconds. Okay, if you're running the older standard spanning tree, that takes a little bit longer. That's about 30 seconds, but it really kind of depends upon how that's configured. Okay, and let's see if there's any other questions that pop in. There's another one here. Is there a charge for the configuration software that was shown? No, this is something that not only can you download from our website to use once you have the radios, is you can actually get that software now and start playing with it. You can actually add dummy radios and start applying this. One of the benefits of doing it that way is that you have the ability to now design your network, and now you can submit that to us. You can email that to us. We can make some comments on it. And you can do this before you've ever received the radio hardware. Okay, good questions. If there's anything else out there, kind of give it a few more minutes. And if not, this video you'll be sent a link to this, the next day or two of the recording of this. It will also be up on our website on essentially our video library. And if you've got any questions, you can give us a call there. My email address is there as well. And it looks like that's about all the questions we've got. So what we can actually, I think we'll go ahead and end things now. Thanks everybody for joining, and have a great day.